we have to find the derivative of I. So we have I of t is equal to 25 sine of 120 pi t. And the derivative of that is equal to 25. The derivative of sine is cosine of 120 pi t. But we also have to multiply by that part right here, which is 120 pi. I get 12 times 25 is 3,000 pi. Okay, 3,000 pi cosine of 120 pi t. Circle this so we don't lose it. And then next thing we want to do is find V of t. So V of t is equal to 5 times 10 to the minus 3 times the derivative of I of t. So we're going to, actually, we're just dividing that by 1,000. But that's not too bad. Okay. So we have 3,000 pi cosine of 120 pi t. We're going to say this is equal to, and we're going to divide this by 1,000, which is easy. 1, 2, 3. So that becomes 3 times 5 is 15. So we get 15 pi cosine of 120 pi t. Okay. So we're on our way. We now have V of t. We have I of t. We need P of t, which is the multiplication of those two together. P of t is going to equal, V of t is 15 pi cosine of 120 pi t. And I of t is 25 sine of 120 pi t. And I get cosine of 120 pi t times sine of 120. 375 pi. Still not too terrible, right? However, if I want to find the maximum, which is the maximum power transferred, I now have to take the derivative of that. And this is where things get a little shaky, but I'm going to try to go a little slowly here. I have to take the derivative of P of t. Remember, to find the max, I'm going to have to set it equal to 0. That's to find maximum. I'm going to start off by saying, let's just pull out the 375 pi because we don't need that. But now, if you look on your sheet, the second to the last one, if you notice, it says f of t times g of t. And that's literally what we have. We have a function times a function. And if you notice, f of t times g of t, which we do, we'll call f of t the cosine, we'll call g of t the sine. This is going to be equal to, I don't really like the way it's written there, so I'm going to write it a little bit easier to remember. So f times g, if I want to take the derivative of that, it's equal to f prime g plus g prime f. What am I saying? I'm saying I'm taking the derivative of f and multiplying it by g, and I'm taking plus, and I'm adding the derivative of g and multiplying by f. I'm going to actually set this up in a way that is organized. And I really, when you get taught this in calculus, I do recommend that you take your piece of paper, put a line down the middle, put some of your work on one side, And then you'll see what I mean. I can keep it somewhat clear. I'm going to first say that my function f is equal to the cosine of 120 pi t. And then I'm going to take the derivative of that, which is equal to the negative sine minus 120 pi times the sine of 120 pi t. Then my g is going to equal the sine of 120 pi t. G prime is going to equal 120 pi times the cosine of 120 pi t. I have everything that I need over there on the side to fill in my function, which is here. Now I can say the derivative of p is equal to, and the first thing I'm going to do is just write the 375 pi, just way out here, because I don't care about that. But I'm going to multiply f prime times g. So I have negative 120 pi times the sine of 120 pi t. That's f prime times g sine of 120 pi t. That's the first term. That's f prime g. I think I'll do it like this. And then plus g prime is 120 pi cosine of 120 pi t, g prime. So g prime times f. Oh, okay. So 120 pi t. I actually don't expect you guys to be able to do all this, by the way. But I do want to show you how it's done. That's why I'm working on it. This equals 375 pi times, now I have this negative 120 pi, but I have the sine of 120 pi t times the sine of 120 pi t, which gives me sine squared of 120 pi t. And then I have plus 120 pi times the cosine squared of 120 pi t. And I can factor out a few things. I can say this is equal to 375 pi times positive 120 pi. I'm going to switch the sine and cosine around so that I have a positive minus a negative. So this is cosine squared of 120 pi t minus sine squared of 120 pi t. We're setting this equal to 0. Well, first I'll divide both sides by this. Times 120 pi. And if I divide the 0 by that, then this goes away and I get 0 equals cosine squared of 120 pi t minus sine squared of 120 pi t. I know that means that sine squared equals cosine squared. We have cosine squared of 120 pi t equals sine squared of 120 pi t. And I can take the square root of both sides, which gives me cosine of 120 pi t is equal to sine of 120 pi t. There's only two places on the unit circle where this is true. We don't really know how to solve equations. We never learned. I can put some videos up, but honestly, we never learned. So, but I do know that in quadrant 1 at pi over 4, sine and cosine are equal. And I also know in quadrant 3, sine and cosine at 5 pi over 4. But remember, these are squared. So it's actually every quadrant has those values. This is 3 pi over 4. And this is 7 pi over 4. It doesn't matter which one of these we pick. Truthfully, since they're getting squared, everything will be fine. How about if we say that theta equals 120 pi t? Then we have cosine of theta equals sine of theta. And now you can see that it's at pi over 4. We're going to put that right back into our original equation, because we now know that the maximum power which occurs when this theta, which is 120 pi t, is equal to pi over 4. My power equation, let's get to back to my original power equation. It's right here. We said P of t is at its maximum when they're positive, it's going to be the maximum. The cosine of pi over 4 is square root of 2 over 2. And the sine of pi over 4 is the square root of 2 over 2, which gives me 375 pi times 2 over 4, which is 1/2. So this is equal to 375 over 2 pi. And that is maximum power, actually.